Hello everyone, in this lecture we'll talk about the inverse matrix, transpose matrix, and the elementary matrix. So let's start by the inverse matrix. If we have a matrix A, we say that another matrix B is the inverse of a matrix B if the multiplication of A by B gives the identity matrix. We defined before the identity matrix that's the matrix that have ones on the main diagonal, so here ones and zeros elsewhere. So this is the identity matrix. So any matrix that when we multiply it by matrix A gives identity is called the inverse matrix, and we usually denote it by A minus 1. So this is can be A minus 1. This is the common notation, but you can use any notation that you want. So when we have this matrix, we say that A is invertible. This matrix A is invertible or non-singular. Sometimes the matrix is not invertible and we can't find this matrix that gives the identity when we multiply it by the matrix A. So in this case, when we can't find the A, we say that A is not invertible, or simply we say that it is singular. And later we will see how to find or to check if the matrix is invertible, and also how to find the inverse matrix of A. So we'll see these methods later. Now here is an example of the inverse an invertible matrix A and its inverse. So here when we multiply A by A minus 1, so here for example, let me erase this part here. So when we multiply A by A minus 1 will be A minus 1 equals, so here 1, 1, 3, 4, 4 minus 1, minus 3, 1, which is equals. So here will be this row times this column, which is 1 times 4, which is 4, 1 times minus 3, which is minus 3. So this is minus 3. This is equals 1. So this is 1. And this row times this column, which is 1 times minus 1, which is minus 1. And 1 times 1, which is plus 1. So it is 1. So it is 0. So this is 0. And this row times this column, which is 3 times 4 minus 4 times 3. This is 3 times 4, which is, let me write it here, 3 times 4 minus 4 times 3. So this is equals 0. 12 minus 12. This is 0. And this row times this column, which is 3 times minus 1, which is minus 3. And 4 times 1, which is 4, so plus 4, which is equals 1. So this is the identity matrix, and that means that this matrix here is the inverse of this matrix. And the inverse is always for the square matrix, so the matrix must have the same n by n, same number of rows and same number of columns. That is, in this case, we can get the inverse of this matrix, or we can check if the matrix is invertible. So for the matrix m by n, where m is different from n, in this case we can't find an inverse matrix. The transpose matrix, or the transpose of an m by n matrix A, usually denoted by A transpose, so A transpose, is the matrix n by n. So here the number of rows of the matrix A transpose is equals to the number of columns of the matrix A, and the number of columns of the A transpose is equal to the number of rows of the matrix A. And we get it by interchanging the rows and columns of A. For example, if we have matrix A equals A, B, C, D, so to get the A transpose matrix of A, we just interchange the rows and columns. So for example, here the row of A, the first row here of A will be the first column here at the A transpose, so it will be A, B here. And the second row here will be the second column here at A transpose, so it will be C, D. This is how we get the A transpose of a matrix. For example, here, the A here, the matrix A here is A transpose is equals. The first row here will be the first column of this matrix, so it will be 1, 1, because the first row, and the second row here will be the second column here, so it will be 3, 4. And even if we have a matrix, for example, a matrix 3 by 4, for example, we call it A, matrix A with 3 by 4, which, for example, we can get this example of 1, 2, 3, 4, 5, 6, 7, 8, and for example 0, 9, 3, 4, for example. This matrix smear is this one. So the transpose of A will be A transpose equals, this matrix will have number of rows equal to number of columns here, so it will be 4 times 3, so it will be 4 times 3, and its transpose will be, so the first row here will be the first column here, so it will be 1, 2, 3, so this row here will be the column here, so 1, 2, 3, 4, and this row here will be the second column here, so it will be 5, 6, 7, 8, and this row here will be the third column, so it will be 0, 9, 3, 4. The elementary matrix is the matrix that we get by interchanging two rows of the identity matrix. So for example, here in the I3, when we change these two rows, for example here, we get E1, for example, we call it E1. So we change these two rows and this stay at this, so the same row here. But we change this row by this. And when we change, for example, these two rows here, the second and the third, we'll get this matrix. And this one, when we change the first and the third row here, we get this elementary matrix. And also if we multiply it by a scalar, for example 2 I3, for example, will be equals 2, 0, 0, 0, 2, 0, and 0, 0, 2. So this is also an elementary matrix, and to get the elementary matrix we do just one operation. So when we change, for example, two rows here, or when we change, for example, when we change and multiply by a scalar, in this case the result won't be elementary matrix. Elementary matrix is the matrix that we get by doing just one operation on the matrix, on the identity matrix.